Hey everybody, it's Miss A and I'm here with YouTube video for our mock STEM fair. I wanted to get the video up there for you in case you needed some information when you're working on your STEM sections. So this is FizzBuzz. It is our Coca-Cola mock STEM fair. So first thing students have to learn is the scientific method. The scientific method talks about the different steps in which you have to go through in order to complete a STEM project. So here is our scenario, and this is the first step to a scientific method, is identifying a problem. The scenario says, I love soda, but unfortunately the bubbles really bother my tummy. I still want to consume soda, but I don't want to deal with the tummy pains. I need to find out which product of my favorite brand of soda contains the least amount of CO2. I really don't like flat soda either, so just open it up and letting the gas escape is not an option. So we have to come up with research. Before we can actually begin, we must do some research to help build our background and help us make informed decisions later when we are designing our investigation. And there is, and I know it's kind of hard to see, there is a sample of research topic notes where we have the date, we put research, and we gather information and we write notes. It doesn't have to be in complete sentences, but they do have to have notes with what they gathered from their sources. Here's an example of our research notes that we took. It says, how can we research to formulate a hypothesis? Research is the gathering of information, possibly on the internet, and taking notes. So those are what the students got together. Now we talked about sources. Your sources can be the internet, but there are some stipulations with that. Nonfiction books, resource books, and qualitative observations. Okay? And we said any website that said .edu is okay to use. If it's .org, class, what do you need to do?
Ask the teacher.
That doesn't rhyme. What is it? .org? Well, that is not the rhyme that I gave them. It was .org. You must check with me. And I think they forgot. So try it again. Class, what are you supposed to do? .org? All right. Well, okay, so they know that if it's a .org, they do need to check with me first because some of those websites aren't as reputable. We do not want .com, with the exception if they are using an FDA nutrition label. Since those are regulated by the government, if they go on to a company's website and get the nutrition label, that is okay because they would be fined if they weren't correct. We also talked about qualitative observations. We could look on our cans, and this is our mock STEM fair, and gather our research information here. So the students actually did investigate the cans, and they gathered research information. So they compared data from the labels because the labels match. They went calories, carbohydrates, sodium, and sugar. And that's how we would do research. They do need to have two sources. Internet is fine for two books are fine. Qualitative observation, I'd like at least one of those and another as an option. Once we have our research, we can formulate a testable topic. It has to have one thing that is being changed, a way of measuring it, and there has to be a reason for doing it. The students will be asked, why is this important to you? So our topic is which soda product contains more CO2, Coke or sugar-free Coke. We'll get into under purpose why it's important to me. Formulating a testable, measurable topic. So that's where we come under here, under testable questions. And it says that I will measure the weight, and this is an example of a note that the students would put down. Now, as a class, we've already come up with a list, so we will write a note about how we contributed to a list and we participated in a vote in order to get our topic, but then each person will talk about why that topic is important to them individually. So, it is necessary to make sure that your investigation topic produces measurable data, quantifiable data, numbers. It has that can be compared, evaluated, and quantified. In the mock project, we will measure the mass of a can before opening it, and we did change this. Instead of every 10 minutes, we're just going to do a 30-minute increment and then determine how much gas has left the can. Ask the kids about the fart scenario. It'll be funny. All right. And purpose is that reason why. Why is it important to you? And that's the personal part of this that belongs to you. Why do you want it? I love soda, so I want to find something that's better for me. All right. Hypothesis. A hypothesis must have a what and a why. So here are our notes from my hypothesis. Your hypothesis must include reasoning due to research. So we have a non-example, and that's why there's a big X. So if I were to say that my friend Daniel is going to wear a dress tomorrow, that is not based on research. I've never seen Daniel wear a dress. He's never made an interest in wearing a dress, and that's not part of our dress code. But if I were to say that I will see Daniel wearing blue tomorrow because he is a Crestwood student and we have a mandatory uniform policy, that is based on research and background data. The what and the why. And a hypothesis statement should say, my hypothesis is, and give the outcome they think is going to happen, and the because statement. The next thing we have is our materials list. Your materials list is everything and anything you need to produce your project. Anything you need. And it must be specific. Everything, be exact. And don't forget your scientific log. You need to have that. So here's an example of the materials list for our topic. 5 12-ounce aluminum cans of regular Coca-Cola. How many I need, what type I need, how big they are, specific. Please note that stuff at the bottom, like the sink and the garbage can, those aren't as specific because they don't affect the outcome of the project. They are just to dispose of garbage and to get rid of products. But you do need to include anything and everything you need. Now, I did tell the students the log has to be on the list. If that's forgotten, you won't get credit for your materials. But if I check the materials and you're doing your investigation and you realize you have forgotten something, it is okay to go back and add it to the list. The last thing we're going to have for today is variables. When scientists design an experiment, they must think about what they are actually testing and the conditions they are testing. There are certain questions all scientists must answer before starting their investigation. What am I measuring? What am I changing on purpose? And what am I keeping the same? The answers to these questions are called their variables. So variables for our investigation, and this is a cute little video that goes into variables. You can search it on YouTube. I put in STEM variables for kids. It's the first video that comes up. What are we going to measure? We're going to measure, and it should be mass, not weight, the mass of the 12-ounce can after opening and before to get how much carbonation is expelled. What are we going to change on purpose? The soda, regular or sugar-free. And what are we keeping the same is everything else. What are we measuring is our dependent variable. It's dependent upon the one thing I change. The one thing I change is independent. Independent means by yourself, so that's the one thing. And then everything else on your materials list will be your constant. All right, this is the beginning part and this week's wrap up of mock STEM fair. I am putting it up there on YouTube so that the kids have it, and it will follow with copies of the STEM logs for the 2 classes. AM class will be first, so if you are in my morning class and you need to copy notes, please look at the morning part, and if you are in my afternoon class, please look at the second set of notes. All right, this starts my morning AM class STEM notes, so I'm going to just hold it for a second. If you need a page, just pause the video. Here's some research for the first class. Hypothesis. And materials notes for today for the first class. Variables notes for today for the first class. Here are the topic ideas that the first class came up with. Students are to look over these ideas and think about which idea is important to them. So these are the options that we can do in class. Why is it important to them? So that they can participate in our democratic vote on STEM Fair. All right, this is my PM class. These are their STEM Fair notes. So they do look slightly different than the first class. Each class is kind of different in a way, so make sure you're copying the right class notes. If you need it, pause the video. And here's an example of one of my second classes. STEM Fair hypothesis. This is a great example. Gives justification based on results. Thank you. Materials and our variables are the STEM ideas that the second class came up with. They are supposed to think about them, why they're important, and make a decision as to what they're going to do so they can participate in the democratic vote.